Welcome to chapter 2. We're studying probability distribution today. Our topic contains random variables. There are two types of random variable, discrete and continuous. The distribution function of discrete random variable is called probability mass function, PMF, and continuous random variable is called PDF, probability density function. Both having the cumulative distribution function. Usually we call it is a distribution function only, and expectation and variance for both the random variable discrete and continuous. That we are going to study for today. Now, what is the need of random variable? The first chapter, which deals with the fundamental probability, its content only depends on random experiment. So if we take a random experiment which is tossing of 3 coins. Tossing of 3 coins. Obviously, the coins are unbiased. Now, its sample space, capital S contain its triple H, HHT, HTH, THH, HTT, TTH, THT and TTT. This is the total number of sample points contained by the sample space of tossing of 3 coins. Now, the question asks, what do you need basically? Means from this experiment, what we are going to find? We are going to find the probability of something, either the number of heads or the number of tails. That's the two possibilities here we can find. Now, if it is only number of heads, we are taking capital X equals to number of heads. Then this triple H contains 3 number of heads. These 3 sample points contain 2 number of heads. These 3 contain 1 and this is 0. So the number of heads, it's only 0, 1, 2 and 3. Previously we have to examine total 8 sample point. Now we have only 4 cases we have to consider. That's mean we need to only examine very small cases compared to the random experiment if we discuss with the sample point except the random variable. That's the need of the random variable, because random variable explain a random experiment in a very low case. Now if you understood this one, we are tossing a coin 100 times. Then the number of sample points equals to 2 to the power 100. 2 to the power 100 means very big number. Now if we consider this one as a random variable only, if capital X be the number, then we need to consider total number of cases. Total number of cases equals to 100 and 0, 1, 2, 3 up to 100. So now you can understand that what is the need of random variable. That's why we are going to study this one in this chapter. Name is probability distribution. Now look at this. For this random experiment, we have 0 head, we have 1, we have 2 and we have 3 head. But there is no 0.5 head, no 1.1 head. These things are not included here. So you will get the probability only for 4 cases. That's why this is called a discrete random variable. So the example for discrete random variable is number of heads, number of tails when you are tossing a coin. Okay, number of 6 when you are throwing a die. So these things are called discrete when it is called a number which only contain 0, 1, 2, the specified number only. Now, if it is talking about the cases distance, then it is continuous. Distance, time, age, height. These are the example of continuous random variable. Now, to know about this, to discuss this one, we need to know about the probability mass function, which specify all the cases with the probability and probability density function, commonly called as PDF, in continuous random variable. So now we are going to discuss probability of mass function. Let if P of x be a PMF associated with a random variable capital X, then P of x follows two properties. First of all, it's a probability, so it must be greater than or equal to 0. And number two, the summation of probability x equals to 1. Obviously, the summation starting from minus infinity to plus infinity. So these are the properties have to follow to be a probability mass function for a discrete random variable capital X. Now, if it is continuous random variable, then let f of x be a PDF, probability density function. Then it also follows two properties, being a probability f of x is greater than or equal to 0, and number two, integration from minus infinity to plus infinity fx dx equals to 1. Since it is continuous, so we can integrate when the sum of the probability can be done by integration. Since it is a discrete case, so we have to take the summation. These are the two differences between the PMF and PDF. Okay. One thing I forgot to tell you, that the random variable capital X is coming from the random experiment sample space to real number. This is a mapping from sample space to real number. So this is the formal definition of random variable. Next, we are going to discuss how you can calculate this one. In these things, how you can calculate the probability from PDF and PM. Okay. Let capital X be a discrete random variable. It's having a value 0, 1, 2 and 3, and its probability P of x is equals to k, 2k, 3k and k square. Okay, these are the probability mass function PMF for the random variable value 0, 1, 2 and 3. To be a PMF, we need to first add this probability of x summation equals to 1. It's giving you k square plus 5k equals to 0. Okay, so k into k plus 5 equals to 0. You will get k equals to 0 or k equals to minus 5. Look at this. For both cases, if it is k equals to 0, k equals to 1 here. So it is k square minus 5k minus 1 equals to 0. So k square plus 6k minus k minus 1 equals to 0. So we take k equals to, no, it's not coming. So k equals to minus b plus minus over b square minus 4 ac, 4 into minus 1 divided by 2 is 8. So minus 5 plus minus 29 root over 29 by 2. These are the two values which can consider to be a PMF. Now one value of this one will be negative. Because if we take minus 5 and minus 29, then it will be negative. So it is a negative value that cannot be a probability of 0 or any one of 1, 2 also. So that's why minus value cannot be taken for kx to be a PMF. So k value is equals to minus 5 plus root over 29 divided by this should be the k value. Now to find the probability for some cases, if we consider probability of x equals to 2, then you will add c into k, just put the k value. Or if it is number 2, probability of x greater than equals to 1, then you will add from 1, 2 and 3, means probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3. Just put the k value and you will get the probability. So this is a very simple thing to find the probability in discrete case. Next we are going to discuss about the probability density function. Okay, let a PDF f of x is defined as x square from minus 2 is equals to x is equals to 2. Let me put here k into x square from minus 2 to plus. Now since it is a PM, it's a PDF, therefore integration from minus 2 to plus 2 k into x square dx equals to 1. Sum of the probability is equals to 1. So what you have to do here, you just integrate k by 3 into x cube from minus 2 to plus 2 equals to 1. So you are getting k by 3. If we put 2 here, then it is 8 minus of minus 8 equals to 1. So total you are getting 16 by 3. So k equals to 3 by 16. This is the k. After getting the 3 value, we can redefine the PDF as f of x equals to 3 by 16 into x square from minus 2 is equals to x is equals to 2. Now you need to find the probability for some cases. Let for example, number 1, we are finding probability from minus 2 less equals to x less than or equals to 1. Since it is a continuous case, so if you are using equal to sign or not using, it does not affect here. Because to integrate a function, we divide this into infinite number of subdivision, and in this infinite number of subdivision, if you delete one of them, you will get the same value, because infinity minus 1 is equals to also infinity. So here, just to find from minus 2 to 1, is and minus 2 to 1 mean you will get 3 by x square, so mean x cube by 16. X cube by 16 or minus 2. So if we put 1, then it is 1 upon 16, and if we put minus 2, then you will get minus minus plus 2 to the power 8 1 by 2. Total you are getting 17 to 9 by 16. So by this way you can calculate the probability. One more thing you need to calculate, you need to communicate here. Look at this, it is defined from minus 2 to plus 2. So if someone is asking you the probability from minus 3 less equals to x less than 1, look at this, integrations will start from minus 3 to 1, but since minus 3 to minus 2, since fx is defined from minus 2 and you are starting from minus 3, so you have to start from minus 2, because the value from minus 3 to minus 2, fx is equals to 0. The same thing can be happen when the upper limit cross 2, so you have to stop at 2. So these two things, if you can remember, you can easily find the probability when a PDF is given to you. Next, we are going to discuss about the distribution function. Distribution function often written as cumulative distribution function. And it is written as CDF, cumulative distribution function. So, in both cases we can find the cumulative distribution function. It is defined as probability of capital X less equals to small x. This is the formal notation for finding the distribution function. Now look at this. You have the upper limit as small x, but you don't have the lower limit. So it is always the probability starting from minus infinity, because lower limit is not given. So lower limit will be always from the lowest point for a real number, which is minus infinity. Similarly, if the upper limit is not given, you will stop at infinity. So minus infinity less than x less equals to small x. This is the thing to find. Now, if it is discrete case, you can use the discrete, and if it is continuous, you can use the continuous. Now, I am giving you an example for crossing of C5. Previously, we have written the sample space. Now, I am writing the probability distribution, means the PML. So, x equals to small x and probability of small x. The values are 0, 1, 2 and 3. Look at this. Since one case is there, so it is 1 by 8. 3 cases for 1 and 2 head, so it is 3 by 8, and last one is also 1. This is the probability mass function for tossing of 3-point random experiment. Now, if you need to find the distribution function, how could you find this one? Look at this. The distribution function f of x equals to, first of all, you will divide this interval into before 0, then 0, then 1, then 1, 2, and then 3. All of them are starting from minus. So, first one is from minus infinity, less than x, okay, less than 0, or you can up to 0, okay, then 0 less equals to x, less equals to 1, then 1 less equals to x, less than 2, 2 less equals to x, less than 3, and 3 less than x, less than n. Now look at this. Before 0, the sum of the probability equals to 0 because nothing is there. So it is 0. Next, 0 is only included, so the probability is 1 upon 8. Next, 1 0 and 1 both are included, so it is 4 by 8, means 1 by 2. Next, I think you can understand this is 7 by 8, and the last one will be all is 1 because this is the sum of all. By this way, you can find the cumulative distribution function for a random variable which is discrete. If we go to find the same thing for a continuous random variable, so continuous random variable, look at this, what will happen. Here we can use the calculus, but it is continuous. So PDF, probability density function, that it is f of x, and distribution function is capital F of small x. Then ddx of fx equals to small x, and similarly integration of fx equals to capital F. These two things you can get it. So here the same thing will be happen as usual as discrete random variable, only you need to use the integration. Now the last topic we are going to study is expectation and variance. Expectation is a probabilistic model. There are two words similar to expectation. One is called average, which one you have like school level, very preliminary school level, and another one is mean, which is a statistical. Both have the same type of method. Only when you are doing it for probability, we call it is expectation. So expectation is nothing but it is a summation of x into x when it is it is a PML, and if the same thing you are using for a continuous random variable, then it is summation from integration from minus infinity to plus infinity x into f of x dx. It is a median. Both way expectation is written as E of x. So E of x means the probability with its number. So if we go for the same example, tossing of 3 coins, then expectation of x equals to, look at this, first one is 0 and its probability is 1 by 8, 1 with 3 by 8, 2 with 3 by 8, and 3 into 1 by 8. You will get also 3 by 8. Since the mean is coming from the measures of central tendency of chapter from statistics. Measures of central tendency. Central tendency means everyone having a tendency to go to the center, means the middle of the data. So middle of the data is always the mean, mode, and median, three different measurement, but all are having the same meaning to go to the middle of the data. Anyway, here expectation also having the same thing. Look at this. You have 0, 1, 2, and the probabilities of them are 1 by 8, 3 by 8, 3 by 8, and 1 by 8. So the middle is here between 1 and 2. That's why it is having the expectation is 3 by 2, which is in the middle of 1 and 2. So you need to remember that expectation is not a probability. This is a number, so it can be from minus infinity to plus infinity, anything, and it can be between two values of your random variable. These two things you need to remember. Next one is variance. Before we go to variance, let me add one thing. Expectation of x to the power n. If it is expectation of x, then it is x into fx. If it is x to the power n, then it is x to the power n into x. This is a simple addition. I have done it for PDF. You can do it for KMF also. Take the summation only. So next one is variance. Variance is a very important measurement of any random variable. It's a property, characteristic of a random variable. Variance is a positive distance measurement from the average or expectation. So that's why if you are taking from the negative side, that is also positive, and positive side obviously it is positive. So variance is the distance from the standard. So standard, what is the standard? Standard is your expectation. Now, how you can calculate this one? Look at this. First of all, if you have the data, I am showing it by the statistics, then I will remove two probability. So first of all, x values are given, let it be 0, 1, 2, and 3. Only this one, these x values are given. If you need to find the average of them, I mean the expectation, then just add them. Total is 6 divided by 4 equals to 3 by 2. To find the variance from these data, what you need to do, you will get variance equals to variance of x equals to 3 by 2 minus 0, or you can make it 0 minus 3 by 2 plus 3 by 2 minus 1 whole square. This square is only to make this one positive. 3 by 2 minus 2 square plus 3 by 2 minus 3 square divided by total number of data. Which one you have seen? 1 upon n summation xi minus x bar its whole square. This is the same formula as it is for statistics. If we go it for the probability, then what is the difference? Next, variance of x equals to sigma square. This is the formal notation for sigma square. We use it for the population. If it is sample, then there will be difference. These things will be discussed in statistical portion. Now this is equals to expectation of x minus mu. Mu is the expectation, its whole square. The same thing, you can expand this one as expectation of x square minus 2 mu x plus mu square, and since constant expectation is constant, so you will get this is equals to expectation of x square minus mu square. This is the calculation for variance. Now let me tell you, variance having the interval, when it lies between the interval 0 and infinity. Now when a data having a greater variance compared to another one, then it is lack of consistency, and if it is inconsistent data, then it is not so reliable. To be a reliable, variance must be low. Next, we will discuss some properties. Properties of expectation. Number 1, expectation of a constant thing equals to constant. Since it it is not changing. Expectation of Ax plus b equals to A into expectation of x plus b, and variance properties are number one, variance of a constant thing equals to 0. Look at this. When every values are constant, then their expectation is also constant. When the same value and the difference of them is equals to 0, so 0 divided by the total number of data, I mean n equals to also 0. Number 2 is variance of Ax plus b equals to a square variance of x plus variance of b, which is constant, so that's why it is equals to 0. So two things here to understood. A is called the origin and b is called the scale. How you can remember this one? Origin means the change of species. The human and the monkey, they both having the different number of chromosomes. So if we change the chromosome, the species will be changed. But in human, there are lots of people who are having taller than other, who are black, white. So these are the difference which is scale. So this thing A is called the origin and B is called the scale. So this is the completion of this chapter. We will discuss the next chapter of probability distribution, some special type of probability distribution both in discrete and continuous in our next chapter. Thank you.